Hey everyone, I welcome you all to this Puppet full course by Simplilearn. In this complete course, we will learn everything that we need to know to excel in Puppet. We have Madhav and Anjali to guide us through this journey. We shall begin with having a basic understanding of Puppet and what is its relevance today. After that, we shall dive deeper and understand the components of Puppet followed by its architecture. After checking its architecture, we shall look at the process to install Puppet and configure it in our local system. Moving forth, we shall see companies that have adopted Puppet and all about writing manifest in Puppet. After that, we will check regarding the Puppet community and Puppet DSL, post which we shall see the hands-on demo that will explain the working of Puppet from scratch. After we have ample knowledge regarding the tool, we shall understand the difference between Chef, Puppet, Ansible and Saltstack. Finally, we shall take a look at some of the interview questions that might increase your chances of cracking any Puppet interview. So before we begin, make sure that you have subscribed to our YouTube channel and don't forget to click that bell icon to never miss an update from Simplilearn. Now without further ado, let's begin with our introduction.
Hello, this is Matthew from Simplilearn. We're going to focus specifically on Puppet. So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network. So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifest templates and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifest, templates, and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, that the current state of the client that is used and communicated back to through the agent.
So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifest, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest, templates, and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just 2 systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate and this signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system And I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact, and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs, and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and it can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes, your systems will be configured.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines, and I have Oracle VM VirtualBox installed on my machine. So on that I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it will sign this certificate. So once your master or the server signs the certificate, you can write your manifests. So the manifests are just the codes for configuration, and once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text. And Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys. Under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall D, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. .512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet dash master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.local domain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Sign certificate request here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets, we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalogs applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo.
So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
Now let's have a look at the Puppet community. The Puppet community is a rich community of a lot of people. Officially, there is no count. But counting the various channels where people collaborate, there are a little over 2,900 committers to GitHub projects who are directly or indirectly associated with Puppet Labs. There are 4,893 modules on the official Puppet Forge. These include modules from the Puppet Labs and also from open source contributors to GitHub. So that's nearly 5,000 modules of ready-made code available on the Puppet Forge. So before you write any code for Puppet, you can check to see if it's already been written by someone. Now there's a mailing list which has 6,588 participants. Apart from this, on Slack Overflow you have a big tag of Puppet Labs and Puppet, which gives you a list of only Puppet questions. That's a good playground for you to interact with people who are already using Puppet and who are contributing and helping others. Now let's have a look at Puppet Forge. So Puppet Forge is a GitHub client for a repository which is hosted by Puppet Labs. It has almost 5,000 modules of Puppet code. So these are both Puppet Labs and community contributed. The best thing about this is that they're easy to customize. So when you have a requirement for anything you're doing with your infrastructure, you can just grab one of those 5,000 modules, and then you can customize it according to your needs. One of the other benefits is they have built-in tests, so they follow all of the best practices. Now, if you write your own module, you also have to write your own tests, and you have to spend extra time writing best practice code. All of that has been taken care of, and you can just download any one of those and customize it according to your needs, and you're good to go. So that's the benefit you get from such a large community, where people contribute to the modules and the code and share with the community. The Puppet DSL. Puppet DSL is a Puppet domain-specific language. It's the Puppet's primary programming language. It's just like plain English, and you don't really need to be a programmer to write code in it. It's kind of a subchild of Ruby because it approaches and uses is equal to and greater than marks to define things. So it's very easy to learn. You can specify packages that you want to install. You can specify services to be managed. You can do things based on the operating system that you have. So we'll be writing a small Puppet module which will be using this Puppet DSL. We will do that after we install the Puppet server and the client. And then we will write a simple Puppet module to show how to use the Puppet DSL. Let's have a look at the demo we are going to do. So you will be setting up the machines using sudo DNS because we want to have a resolvable DNS. Because only by having a resolvable DNS can we use Puppet, because Puppet uses the SSL certificates. Now we'll be installing the Puppet server and the client. We'll be signing the certificates of the client on the server side. And then we'll proceed with writing an NTP module, which we'll be using for installation of NTP on the client. And then we'll look at the Puppet programming language, or DSL. Now, we are going to look at a demo here. So we will be setting up the machines. We'll set up a sudo DNS locally because Puppet requires a fully qualified domain name in order to run, since there is a certificate communication taking place here. We will be installing the Puppet server, the Puppet client. We'll be signing the certificate, and finally we will write an NTP module and make it run. So now we will be starting a Puppet master and a client. I have two machines here. One is the Puppet master and the second is the Puppet client. The Puppet master has got almost 4 gig of RAM and 4 vCPUs, which I can show you here. Because it's a Ruby on Rails application, it requires a lot of CPU and RAM. For the client, I don't need that much RAM and CPU, so I've allotted 1 gigabyte of RAM and 1 vCPU. I will start both of these machines and find out the IP addresses. Right-click, normal start. Both of these machines are starting up. The Puppet client has started up, and the first thing I'll do is log in using root and Red Hat password, and then I will change the host name. So I'll say vim etc host name. This will open a hostname file in a text editor, which is vim. Then we'll do a DD, which will delete that existing host name. And then I press the I for insert mode, and finally I'll type the puppet-client, which will be the host name of this machine. I'll save this file by doing escape semicolon WQ exclamation mark. And I'll reboot the machine. Similarly, going to the Puppet Master, I'll say root red hat. I'll open the hostname file. Say DD, then I'll say puppet-master. I'll save this file and reboot the machine for the hostname change to take effect. The hostname change does not take effect unless you reboot the machine. Now both of these machines are ready. I'm going to find out the IPs and use the Mac terminal to log into these. So this is 23 and 21. So 23 is my server and 21 is my client. I'll SSH to 23 first. Now, in order for the Puppet Master to be installed, I need a fully qualified domain name here and a fake DNS, which means a fully resolvable DNS name. So if I do host name here, you see my host name is Puppet Master. In order to set up a fake DNS, I need to go to the etc host file, go to the end, then I say IP address, host name local, then space host name. Now, this is one of the techniques which makes the Linux server believe that there's a fully qualified domain name on this machine. I'll save this. Then I do a host name -f. You see it has a fully qualified domain name now. So now we will be downloading the Puppet Labs repository for Ubuntu 16.04, which is Xennial. So I'll say curl -0 https apt.puppetlabs.com /puppetlabs-release -pc1 -xennial.deb. You can see there's a Debian file which has been downloaded here. I will import this using the dpkg command. So I'll say dpkg-i puppetlabs-release -pc1 -xennial.deb. And then I'll say apt-get update, which will update my apt package indexes on this machine. And now I'll install the Puppet server. So I'll say apt-get install puppet server -y. So the Puppet server is now installed, and we will be configuring the memory allocation for the Puppet server. So I'll say etc default Puppet server. So by default, it has only got 2 GB allocated. We'll give it 3 GB because it's JVM. I'll make this 3, and I'll change this to 3 as well. And I'll save this file. I'll make sure the unconfigured firewall allows port 8140, which is the Puppet Lab Puppet server port. The rules have been updated to allow that. I'll now start the Puppet server. So I'll say systemctl start Puppet server. It takes some time because it's a JVM, so it takes a couple of minutes to start the Puppet server. So the Puppet server is now running. I'll also enable it at boot time. So I'll say systemctl enable Puppet server. It will enable at boot time. Now I also need to configure a fully qualified domain name here. So I'll do that by going into the hosts file. I'll go to the end and I'll say 192.168.1.23 and then puppet-server.local and then puppet-server. If I do a hostname -f, put -master.local because the current hostname is puppet-master. So the trick is to have the hostname.local in front of the IP address in the host file. Having a fully qualified domain name now we will go to the client setup. The client setup is almost the same with just a small difference. The package which we need to install on the client is Puppet Agent. So we will go to the client. So you see this has got a host name. Now we also need to set up the fake DNS here. So I'll copy this host name, open the host line, go to the end, write the IP address, and then .local, and then host name again. So this will give me a fully qualified domain name. So when I do a host name, it says puppet-client. When I do a host name -f, it says puppet client local. To install the Puppet agent on this machine, I will need to download the Xenio packages. So I'll say wget https apt.puppetlabs.com/puppetlabs -release -pc1 -xenio.deb. I'll download this, and then I'll say dpkg-i puppetlabs -release -pc1 -xenio.deb. So this is the repository package which I'll be downloading here. And then I'll say apt-get update-y. This will update my apt caches on this machine. And now I'll finally install the Puppet agent. So I'll say apt-get install Puppet agent -y. Now the Puppet agent is here. I'll start the Puppet agent and I'll enable it at boot time. So I'll say system control, start Puppet, then system control, enable Puppet. Now Puppet is enabled. Now we have set up the fully qualified domain name on the client and the server, but each of them should know each other. So we'll have to do a cross-certificate host mapping. So we will be copying the host file entry of the client and adding it to the server. So I'll go to the etc hosts on the server side. Go to the end, paste it there. Okay, and I'll be adding the entry of the master on the client side. Okay, now both of the servers will recognize each other now, because one of them has the host entry of the other. So if I do from the master ping puppet-agent.local, if I ping the agent from the server, -client.local, it is able to ping it. And if I ping the master from the client, if I say ping puppet-master.local, both of them will be able to ping each other. Now the next step would be to create a certificate signing request. So I'll go to to this directory, which is opt puppet labs puppet bin, and I'll say puppet agent -t -server is equal to, and I'll give the fully qualified domain name of the Puppet master. Then I'll say -f. When I do this, it will create a certificate signing request, you see. Now, if I go to the server and I do an opt I'll check and see how many certificates are pending to be signed. You'll see there is a Puppet client certificate which is pending to be signed, which is denoted by the absence of a plus sign here. I'll be signing the certificate, so I'll say Puppet cert sign and then the name. So Puppet-client.local. This will sign the certificates. And when I go to the server on the client side, if I run the Puppet agent again, you see it's actually pulling down the catalog. As of now, it has an empty catalog. That says there is nothing. Now we have configured the Puppet agent and the master. Now we will be taking a module from Puppet Forge. Puppet Forge is a big collection of open source modules which are free to use. As a first step, we will be using a ready-made module, and that would be a demonstration for how to actually get up and running with a module. So search for Apache module here. This is the Puppet Labs Apache module. I'll be using the Puppet command line, Puppet module install. This is the command for that. But I will make sure I run this command from the Puppet home. So I'll go to the master, I'll go to etc Puppet Labs, code, environments, production. In this, I'll do modules. Now I will run it from the binary which is present at the opt Puppet Labs bin Puppet. And then module install. Puppet Labs-Apache, and then this version. So we are specifying the latest version, and I'll hit enter. When I press enter, it starts downloading from the Forge API. So you see the module is downloaded in addition to the dependencies. So there is concat, stdlib, and Apache. So now I'll go to a folder here which is one level up called manifests. So this is the file here, etc Puppet Labs code environments production manifests. So in this there's a file which I'll be creating called site.pp. The site.pp will specify, and this is the main controller of how the infrastructure looks. In the site.pp, I specify that I want puppet-client.local node to have the Apache module included. I'll save this file, and the only thing I need to do now is, since all is set on the server side, I need to go to the client side and run Puppet agent. It will automatically download the Apache module and compile it, and then make sure the server is in a state. So when I press enter, we see a lot of output. It tries to configure Apache on this machine, and done. Now when I go to the front end of this machine, on this port, I should be able to see Apache's default page. So this is Apache's default page. So the module which we downloaded from the Forge was actually written in a way that Apache would be installed and run at boot time. So that is why it is running here. And that is all we have from the Puppet module. And this concludes the demo.
Today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or Saltstack? All four are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and Saltstack. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef.
And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find as a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang. And it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from a beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. The more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. It is the way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. this is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, Saltstack. So Saltstack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via Saltstack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that Saltstack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with Saltstack. So Saltstack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that Saltstack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all 4 tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and Saltstack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network. And there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the 4 tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and Saltstack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have 2 different types of language, with both Chef and Ansible being procedural in that they actually specify at how you're actually supposed to do the task in your instructions. With Puppet and Saltstack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our 4 contenders? So again, we have a 2-way split. With Ansible and Saltstack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all 4 cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and Saltstack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our 4 tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and Saltstack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all four tools are very secure in their communication. So who wins? Well, here's the reality. All four tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these four tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you.
In this video, we have compiled the most important interview questions of configuration management tools, Chef, Ansible, and Puppet that you might face in a DevOps interview. So without further ado, let's get started.
So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is hashtag systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively, and one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do what is the command to sign a requested certificate, the top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the three options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the three tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are four. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide differences between Ansible and Puppet. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture.
And with that, we have come to an end of this tutorial on Puppet. I hope this tutorial was informative and interesting. If you have any queries regarding the topics covered in this tutorial, then please feel free to let us know in the comment section below. Our team of experts will be happy to solve all your queries. Until next time, thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.